Okay, so for the following circuit here, we have to find VO and IO. So pretty much this and then this. So since this is an ideal op amp, the current passing through here will be 0, and so will the current passing through here. And that means, and we know that the voltage difference between these 2 points will also be 0. So the voltage here and the voltage here will be the same. So we can find the voltage here. It's going to be 0 volts because it's connected to the ground node. And that means the voltage here will also be 0 volts. Now we can use that information to find the current passing through this current and this current. Okay? And then through that information, we can find what the current is, the current value of this. Okay? So pretty much this region, we see that as I3 enters, it's going to be equal to the I3 will be here as well, because since this is since this wire I is equal to 0, we can practically just ignore it. So imagine this as just one continuous wire. Okay, so we can put I3 here. So I1 plus did I write I1 2 times? Sorry, let's call this I2. I1 plus I2 plus I3. Okay, so let's just let's find I1 and I2 and solve for I3. So I1, it will be equal to 2 minus 0. Recall this whole region is 0 volts. So 2 minus 0 all over 5,000 ohms. And that gives me 4 times 10 to the minus 4 amps. I2 will be 1 minus 0 all over 2,500 ohms. And that gives me 4 times 10 to the minus 4 amps again. Okay? So I3 will just be equal to minus I1 minus I2. So it'll be minus 4 times 10 to the minus 4 minus 4 times 10 to the minus 4. And that's just minus 8 times 10 to the minus 4. And now we can use that to find the voltage here. Okay? So so the voltage here will actually be VO, because if we go down this way, if our current goes down this way, then this is what's going to happen. It's going to, since it leaves from the negative terminal, it must drop by VO and equal 0 volts as we hit the ground. So VO minus VO will give you 0 volts. So that means this region will be VO. So we can write VO minus 0, because recall, so VO minus 0 all over 10,000 ohms is equal to I3. And I3 is minus 8 times 10 to the minus 4. So VO will be, give me a quick second. VO will be minus 8 volts. And now we can use that information to find IO. So we see IO will be equal to these two currents that are leaving it. So this current is I3. So see, IO is entering this node, and these two are leaving it. So IO enters, I3 leaves, and let's call this VO. And then IVO leaves as well. So I3, we already know the value. It's minus 8 times 10 to the minus 4. Okay. What else? And then IVO, let's try and solve that one. It's going to be pretty much VO all over 2,000 ohms. So that's going to be minus 8 over 2,000. That's going to be our IVO. So that's minus 4 times 10 to the minus 3. So this will be minus 4 times 10 to the minus 3. This is what's going to be your IO value. and that's minus 4.8 times 10 to the minus 3 amps, or just minus 4.8 milliamps.